from Standing Waves in Strings and Pipes, and this is lesson 11 for year 13 physics, and it has to do with changing the frequency of a note. Now, one way of doing that is by changing the length of the string or pipe. So what happens when you change the length of the string or pipe? It effectively changes the wavelength. Now, since V equals F lambda, the wave speed remains the same, so the frequency or pitch will change. Now, just remember, in your answer, do not use the word change, because I'm thinking most probably the question would be to either decrease or increase the length. So instead of the word change, you need to use the word smaller or bigger or higher or lower or longer or shorter. You need to use those words and don't use the word change. Okay, the other one is changing the tension of the string. So sound travels faster through tighter strings. So if you increase the tension of the string, the speed of the wave will increase. However, you haven't changed the length of the string, so the wavelength stays the same. Since V equals F lambda, increasing the tension will result in a note of higher frequency or higher pitch. The other way is by using a thicker or heavier string. Sound travels slower through heavier strings, so using a thicker string decreases the wave speed. The wavelength stays the same, and since V equals F lambda, the frequency decreases when a thicker string is used. Now, why does a guitar playing A, which is 440 Hz, sound different to a piano playing the same note? So, here's the answer. Both instruments produce 440 Hz. In addition to this, they also produce higher harmonics, which are exact multiples of 440 Hz. The amplitude of these harmonics is different for different instruments. So what we hear is the combined effect of these harmonics added together. So the fundamental will always sound the loudest, but the higher harmonics will have different amplitudes for different instruments, and what you hear is the combination of all this. And that's why every instrument sounds different.